6.12. I'm going to go through this one kind of quick. It's a lot of review. So in the ready, very few problems in the ready. It just wants you to find the tangent of theta. Remember, tangent is y over x. And look at that. You are given y and x for each of these. So this should be relatively easy. Remember, rationalize your denominators. Number 4, you can't have a square root in the denominator, so you do need to rationalize that. Simplify your fractions when you can, please. Don't leave them. All right. I'm going to change your directions for set. This is a matching type of problem. I will know that you guys did not watch the video if you are not following my directions. I would like to see you take these 4 and I would like you to graph them. 2 of them are easy. These 2, A and B, are easy. 6 and 7 do have a phase shift. Use Desmos. You're already on your Chromebook. Use Desmos to check to see if you did graph them correctly, please. Identify amplitude, period, vertical shift, phase shift, y-intercept. Do an analysis and then use that to graph. In these 4, I would like you to write the equation. And if you really want to challenge yourself, you can write the equation for sine and cosine. But you guys can also just go ahead and write it the way you see it. If you, for example, 8, I look at 8 and I see cosine. Write it as cosine. But if you want to challenge yourself, you could write it as cosine, but then say, wait a second, it's also sine. And for the increments, go ahead and make every 4th 2 pi for all of these. Every 4th mark 2 pi, and then for the y-axis, make every mark 1. So you guys can go through, you can find the periods, you can find amplitude, phase shifts. Challenge yourself, you guys. Don't just take the easy way out. I know some of you will challenge yourselves. Most of you are going to take the easy way. Maybe you'll surprise yourself. Maybe you'll actually get it. And then you can plug your equation into Desmos and see if you got it. See if you get this graph back. Now these last 4 are really challenging, but try and graph them. Or at least do an analysis. If you are kind of feeling like I'm done with graphing, just identify the amplitude, the period, vertical shift, phase shift, maybe even throw in a y-intercept. Do an analysis, and then who knows? Maybe you will realize, oh, I can graph this. I have everything I need. So, again, challenge yourself here. You guys have a test on Tuesday where you are going to have to be doing this stuff. Maybe not so much with the phase shift, but if you can graph a phase shift, you guys, you can graph sine and cosine. Challenge yourselves. I'm not worried about 12 and 13. 14, you're not graphing, you are identifying amplitude, period. Your horizontal shift, that's your phase shift. And then you have the vertical shift. Please challenge yourselves here and do them. Do not look at these equations and think, oh, it's too difficult. There's fractions. I don't want to deal with this. I'm going to be lazy. These are actually more of what your final is going to be like that we take in May. They are going to have more complex equations on there. You need to be ready for those. So this would be a good place to start practicing complex equations and not just the simple ones that we see back here like in 6, 7, or A and B. Challenge yourself, please. Now, the go. Some of these are easy, some of these are not so easy. We have composite trig functions. So it's a function within a function. Now we need to remember, inverses undo each other. If I have the sine of theta equals 1/3, I can get theta by itself because I am taking the inverse of both sides. So that cancels, and I have sine inverse of 1/3. It's the same idea here. Inverses of the same thing will undo itself. So if I see sine of sine inverse, let's say it's 2/3. Well, sine and sine inverse undo themselves, and I am left with 2/3. It's the same with cosine. It's the same with tangent. They undo themselves. The tricky part is when they're not the same function. When you have a sine and a cosine together, or a cosine and a sine, or a tangent with a cosine, you're going to need your unit circle. The first three here, look, they're the same functions. So that should be relatively easy for you guys to come up with the answer. But then when you get to these next ones, they're not so easy. Notice how these are on your unit circle. All of these are values that are on your unit circle, except for the 2.75, which you will then need to use your calculator for. I'll help you. We'll do a couple right now. You might need to watch this a couple of times before it really sinks in. So let's say we have sine cosine inverse root 2 over 2. Root 2 over 2 is on my unit circle. You want to start with the inside. Cosine inverse, the question is, where is cosine root 2 over 2? You want to find theta. So this actually is written as, this is written as cosine of theta equals root 2 over 2. We need to figure out where is cosine root 2 over 2. Now I'm looking at my unit circle, and there are a couple of places where the cosine is root 2 over 2. Quadrants 1 and quadrants 4. You are welcome to practice using both, but only one of them actually is the correct answer. We are not graphing right now what the inverse of these functions look like, but cosine inverse and sine inverse's graphs actually look like this. Well, better than that, but they do run vertically instead of horizontally, which makes their inverses non-functions. So we have to limit what we look at. So we change the domain, and we change the range, because we want to look at this as if it is a function. So for cosine, I'm just going to give you this little hint right now. Those of you who are going to take math analysis, we actually cover it more in depth in math analysis. For cosine, you are actually only going to look in quadrants 1 and quadrants 2. That's for cosine. For sine, in order for the inverse to be a function, you will only look in quadrants 1 and quadrants 4. Everything else makes the inverses non-functions. You guys can graph this in Desmos, and you can see for yourself what the graph looks like, and that it is clearly not a function. It does not pass the vertical line test. Oh, sorry. So if I'm looking, where is cosine root 2 over 2? I see that theta is pi over 4. So I still have this sine. So now I want the sine at pi over 4, which luckily happens to be root 2 over 2. It's the only place that it actually happens is the pi over 4. Let me give you another one. Let's say we have cosine sine inverse negative root 3 over 2. So this one is asking us, where is sine negative root 3 over 2. That's what we need. We're undoing the inverse. Where is sine? Negative root 3 over 2. Now remember, sine, you are looking in quadrants 1 and quadrants 4. Sine is negative in quadrant 4. Where is sine? Negative root 3 over 2. Take the time, look. I want you guys to find it. Don't just sit there. Did you guys find it? I hope you have 5 pi over 3. Sine is negative root 3 over 2 at 5 pi over 3. Now I'm going to bring my cosine down. And now I want the cosine at 5 pi over 3. So you're already there. The cosine at 5 pi over 3 is 1/2. So they're not too bad, you guys. Again, you could use your calculator if you, for like the ones that aren't on the unit circle. I really want you guys to focus on the ones that are on the unit circle. If you don't do 21, I'm okay with that. But the rest of these, they're on your unit circle. So have fun with those. These are some of my favorite types of problems, especially when they're on the unit circle. Very nice when they're on the unit circle. If you have questions, ask Mr. Rivas or save them for Friday or Monday. And you finish this, move on to 6.13.